This video provides an introduction to the independent t-test. Are women better investors than men? A researcher studied trading activity and annual returns of individuals who made their own investment decisions without the advice of financial advisors. His conclusion: women make more money in the stock market than men. A recent study looked at the ability to delay gratification in young children who were assigned to one of two treatment conditions: reliable or unreliable interactions with the experimenter. The results indicated that children who experienced reliable interactions before the marshmallow task waited significantly longer before eating the marshmallow than those who experienced unreliable interactions. The appropriate test for these studies is the independent t-test, which examines differences between two independent population means. The test involves one categorical independent variable with two levels and one quantitative dependent variable. Here are the test assumptions. 3 of these are the same as the one-sample t-test, extended to 2 samples. The second assumption, independent samples, means that subjects cannot be in both groups. The last assumption is tested in SPSS using the Levene test. Meeting the assumption allows us to pool information from both samples in order to calculate a pooled estimate of population variability. Suppose we're doing a case control study comparing dietary fiber intake for men with colon cancer and those who do not have colon cancer. We'll draw random samples from both populations and use a significance level of 0.05. The independent variable is disease state, cancer or no cancer, and the dependent variable is daily fiber consumption, measured in grams. We want to know whether there is a difference in mean fiber consumption between the two groups. The null hypothesis is that the population means are equal, or that the difference between means is 0. The research hypothesis is that the means are not equal, or that the difference is not 0. The first assumption is met, and we have independent samples. It is also not likely that knowing one subject's fiber consumption will tell us anything about another subject's fiber consumption. Our total sample size will be large, so the sampling distribution of mean differences will be approximately normal. We use the Levene test in SPSS to test the equal variances assumption. Now we collect the data and run an independent t-test in SPSS. Let's see what the results look like. The first table shows descriptive statistics. This is the same information you see with the one-sample t-test, but for 2 groups. The independent variable is listed here, and the dependent variable is shown here. The sample mean is lower for cases, but the t-test will tell us whether this difference is statistically significant. The first part of the next table shows results of the Levene test, which tests the null hypothesis that the population variances are equal. The equal variance assumption is met whenever the p-value is large. When this is the case, we interpret the top row when we look at the t-test results. The second part of the table shows these results. The label at the top indicates that this is the t-test, testing the null hypothesis that the population means are equal. The equal variance assumption was met, so we interpret the top row. The calculated t-value is equal to the mean difference divided by the standard error. The degrees of freedom is equal to the total sample size minus 2, and we can see that the p-value is greater than alpha, so the null hypothesis is not rejected. The last part of the table is the confidence interval results, which we don't interpret because the t-test results were not statistically significant. This is what the whole table looks like. Levene test results on the left, followed by t-test results and the confidence interval. In our summary, we indicate that there is no significant difference in mean dietary fiber consumption. The independent t-test is used to test hypotheses involving 2 independent population means. If the equal variance assumption is met, we can pool information from each sample to get an estimate of population variability. If it is not met, we use a separate procedure.